Elements of the periodic table. Today we're going to talk about what possible binary compounds you can form with hydrogen. Let's start with the halogen family. Yeah, I like that idea. In my case, it's called hydrogen fluoride. For me, it's similar too. It's called hydrogen chloride. Same here, hydrogen bromide. Yeah, hydrogen iodide. Well, this is absolutely wonderful. So it seems that the halogens can all form compounds that are named with my name and theirs, but with an IDE ending. Fluorine, can you please explain to me why that is? Yes, of course, hydrogen. That's because we only form one bond, and we are also more electronegative than you. Oh, I see it now. Well, now let's move on to the chalcogen family. Okay, us chalcogens can form two bonds, but our naming system is not as straightforward as the halogens. In my case, it's called water. Well, that's kind of interesting, oxygen. But in my case, it's called hydrogen sulfide. I'm also on board with sulfur. It is called hydrogen selenide in my case. My analog is not nearly as stable, but it is also called hydrogen telluride. Well, that's definitely different from what I was expecting. Well, let's move on then. Pnictogen family. Are your rules similar to that of oxygen and the chalcogens? Well, we form three bonds, but our naming system is also quite different from the other two. In our case, we have INE endings at the ends of the names. But not me, because I'm the most electronegative of the bunch. In my case, it's called ammonia. I see where you're going with this, nitrogen. In my case, it's called phosphine. Same here. In my case, it's called arsine. Well, for me, it actually is a little different as well. Not in terms of the ending, but the beginning, because my name for this analog is derived from the Latin root. So in my case, it's called stibine, as you can tell from my chemical symbol. Oh, I see it now. So we seem to be coming to a pattern here. The further towards the left you go from the right side, the more inconsistent things become. Crystallogens, are you guys like this too? Yes, we are. We form four bonds, and my name is a little different from the others, but our endings are all the same. We all have ANE endings. In my case, it's called methane. For me, it's called silane. I agree as well, germane. And just as my neighbor Antimony said, my analog has a different prefix at the beginning. So for me, it's called stannane. Well, we seem to be coming quite a ways now, wouldn't we say? Oh, boron, your family still has to participate. How about you? What do you have to offer? Well, actually, things are a little different for me as well. Really? How so? Well, you see, hydrogen, I'm the only member of my group that is not a metal. I am a metalloid, like silicon, germanium, and arsenic. But I do form a compound with you also. In my case, it's called diborane. Fascinating. Can you please explain to me why that is, boron? Oh, yes, of course. That's because I don't have a full octet. So to make my molecule stable, two of us have to dimer together. So we form a larger molecule as a result of that. Oh, I see. And dimer means to pair up, right? Yes, you got it. Well, elements, this has been fun. Hopefully we can talk about more hydrogen compounds in the next video.